Imagine it's been a while since your morning cup of coffee. You have a big presentation at work in about an hour, and then it hits. A sharp pain in your gut that quickly makes its way to your face. Yep, you got that death stare from across the room. Your boss is mad at you for something you didn't do, but he thinks you did. Like you need more stress in your life. Here's what to do. Grab your stuff and run out of the office. Get yourself to a quiet spot away from other people and try to calm down. Okay, now take a few deep breaths, relax, and watch this video about supervolcanoes. Hey there, welcome to my channel. Let's get into it. Scientists can predict when Mount Vesuvius will erupt again. So if they can forecast when a volcano that's taken 17 centuries off will blow again, you'd think that predicting eruptions would be pretty foolproof by now, especially when it comes to supervolcanoes. We just don't have enough time to wait for those to happen. That said, scientists are getting better at it. And to understand how they do it, let's start with Mount Vesuvius. In 79 AD, Vesuvius erupted, burying the Roman city of Pompeii in ash. But the eruption wasn't unprecedented. People had been living near Vesuvius for centuries before that. And it won't be the last time either. It's overdue for an eruption. And because it's one of the most densely populated regions in Europe, it could be a major disaster. To figure out when it might happen, scientists look for signs in the physical structure of the volcano. For example, between eruptions, the magma chamber below Vesuvius refills with magma, and as it does, it bulges the ground above it. With satellites, we can measure how fast that's happening. If the bulge grows faster than usual, that might mean an eruption is near. There's also seismic activity. The magma moving around creates vibrations in the rock. So studying those tells us how much magma is moving and where it's going. If that magma reaches the surface, we get an earthquake. If it doesn't, we get a silent magma ascent. All these clues help scientists figure out when to expect another eruption. The same goes for the Long Valley Caldera in California. This supervolcano last erupted 760,000 years ago. And based on what we know about its past eruptions and the patterns of earthquakes and ground deformation in the area, scientists estimate it'll probably blow again in about 125,000 years. But there's another way to tell whether or not a supervolcano is about to erupt, one that might help us forecast eruptions of volcanoes that haven't erupted in thousands of years. And it starts with the chemistry of volcanic eruptions. When a volcano erupts, it releases gases like water vapor, carbon dioxide, sulfur dioxide, and hydrogen sulfide. The amount of gas released during an eruption depends on how hot the magma is, how quickly it's moving, and how deeply it's buried. The deeper the magma is, the more pressure it's under and the more gas gets dissolved into it. So the deeper it is, the less gas escapes during an eruption. Scientists can measure how much gas is escaping from volcanoes with instruments called gas flux systems, which are basically tubes with filters that collect volcanic gases. Some gases escape directly from the magma. Others come from hot steam heated by the magma. These gases can travel long distances through cracks in the Earth's surface before they dissipate. So gas flux systems can be placed miles from the volcano, sampling gases that have made their way through underground pathways. And here's the thing, when scientists analyze the mix of gases coming from a volcano, they can figure out how deep the magma is and how quickly it's moving towards the surface. Magma that's deeper and moving slower has more dissolved gas in it. And that's important for forecasting supervolcanic eruptions because magma with a lot of dissolved gas in it tends to be more explosive. For example, in 2013, scientists used gas flux systems to study Augustine volcano in Alaska. They found that the magma was moving faster than it had in the previous decade, and that it came from a much deeper magma source than expected. And in June 2018, Augustine erupted, sending an ash cloud 15 kilometers into the atmosphere. Scientists were able to use the gas flux system data to show that the 2018 eruption was much more explosive than it would have been if the magma hadn't come from such a deep source. Plus, scientists can use gas flux systems to track changes in magma over time. Studying the chemistry of gases coming from a volcano gives us insight into the magma beneath it, which helps us figure out if it's becoming more or less likely to erupt. Here's how it works. First, a little bit of the magma makes its way up through the Earth's crust. As it travels, it reacts with the rocks around it, picking up elements like hydrogen and chlorine and fluorine that become part of the magma. Then as it continues to rise, some of those elements turn into gases and start to bubble out of the magma. Those gases dissolve back into the magma as they rise, creating an ever-changing chemical soup. And depending on the ratios of different elements in that magma, scientists can tell if it's likely to explode. Magma with high concentrations of fluorine and chlorine is likely to be more explosive because those elements make more gas bubbles that put more pressure on the surrounding rock. And as that pressure rises, the likelihood of an eruption increases. But remember, all of this depends on the ratio of these elements. Too much water and not enough of those other elements means that there will be lots of gas bubbles, but they'll be too far apart to boost the pressure enough to cause an eruption. Not enough water and too much of those other elements means there won't be many gas bubbles at all. So scientists need to find the right mix of all these elements to increase the chance of a supervolcanic eruption. Researchers have tested this method on historical records of volcanic eruptions. By measuring the gas flux from volcanoes after they've erupted, scientists can compare the composition of magma before and after an eruption. And so far, it looks like the ratio of fluorine to water that seems to predict explosive eruptions is a 1-to-1 ratio. In other words, when the amount of fluorine is equal to the amount of water in the magma, conditions are prime for an eruption. But you can't always predict exactly when a volcano will reach that ratio. And testing this method on real volcanoes is tricky, because researchers have to get really close to potentially active volcanoes to set up their gas flux systems. Like they tried to test it out on Mount Vesuvius in Indonesia, but they had to abandon their experiment when the volcano started to show signs that it might erupt. Still, there are places where scientists can safely measure the gas emissions and get a sense of whether or not they should be keeping an eye on things. For instance, at Yellowstone, scientists have set up gas flux systems along the edges of the caldera. The hope is that if they can find magma with the right chemical recipe, they can look for other signs of an eruption, like ground deformation and seismic activity, to figure out if an eruption is actually on its way. So scientists are working on ways to forecast eruptions that take into account gas chemistry, but also the physical structure of volcanoes. At Mount Vesuvius, researchers combined gas measurements with ground deformation data, and they found that when the magma had the right fluorine to water ratio, the ground began to bulge more rapidly, suggesting an eruption was imminent. It's still early days for this forecasting method, but it's showing promise. And as scientists continue to track volcanoes around the world, they'll get better and better at predicting when they'll erupt. And maybe someday, soon, they'll even be able to predict when a volcano will erupt just by looking at the gases coming from it. Now, check out this video about what would happen if a supervolcano erupted today. Or this video about why it might not be the worst idea to live near a volcano.